How's it going, guys? Today I want to go over another LeetCode question. Today our question is called reverse vowels of a string, and this is a question that's currently being asked by Amazon right now. Alright guys, today our question is called reverse vowels of a string. Again, it's a question that's being asked by Amazon right now, and our problem description says, write a function that takes a string as input and reverse only the vowels of a string. So in our first example, if we're given the string hello, we want to return a string that has the E and the O of hello reversed. So hola, hole, hole. In our example 2 here, we have LeetCode, classic LeetCode example here. And we would output Leo to Sede. And that would basically be the string LeetCode, but with the vowels reversed, right? So let's like walk through that to make sure we understand why that's the output. So what we're really doing is we're finding a vowel on the left side, we're finding a vowel on the right side, we're reversing them. So we're finding the two O's and then reversing them. Then we're walking forward, finding another E, and then we're finding an O in this case, right? And we're reversing those two characters. So eventually, this is our output. And as a quick note, it tells us that the vowels don't include the letter Y. English is weird. I never really understood that sometimes Y could be a vowel. And so in this case, that would probably be a good clarifying question to actually ask your interviewer, is Y considered a vowel in this case? And they would tell you no, I guess. Okay, great. So we have a couple components to this problem, right? Really the first part is just being able to identify whether or not something is a vowel or not, right? Any given character. And the second part is the logic to actually reverse things in a string. So a good point to mention is probably in Java, at least for me or anyone else doing Java, is that strings are immutable. So we would have to actually change the string from a string to a character array to do any kind of string manipulation, first and foremost. And then the next thing is, how are we actually going to determine, right, if something is a vowel? And one way we could do that is we could just say these are all vowels, right? And we could maybe be a string or something like that, and we could just ask for each character, is this thing a vowel, right? And then we could run through our string and check all the characters individually, but that's not super efficient. So what we could do is we could basically just make a hash set of characters and just throw all our vowels in there, and that will give us O of one time to determine whether or not a character is a vowel, or constant time access to whether or not something is or isn't a vowel. So that's really easy to do. So the first thing we could do basically is just make that hash set. We could throw all our characters into that hash set that are vowels. And then once we have that hash set, we can basically start doing that logic, right? We could have 2 pointers, and we want to find a vowel on each of those pointers. And if we have found a vowel for each of those pointers, we can reverse those characters, right? We can essentially swap those characters and then keep moving until our pointers have crossed. So let's start writing that logic. So the first thing we want is a set of characters, right, that's going to represent all of our vowels. So we could say set of characters, and it's going to have all our vowels, so we can call it vowels equals new hash set. And now there's not really a super efficient way in Java to create a hash set or a set with specific things already initialized. So now we actually have to add line by line all of our vowels. And it doesn't say, right, we could have uppercase and lowercase vowels. So that's another kind of like edge case thing that we should take care of, and we should probably ask our interviewer as well. Will our input string contain only lowercase letters, uppercase and lowercase letters, and make this vowel hash set accordingly? So we're just going to add uppercase and lowercase vowels now. So we're just going to say vowels.add, and we'll add an A, and now we'll just copy and paste this for the sake of time. So uppercase A, lowercase a, E, E, I, O, and U, and U. Great, so now we actually have our hash set of vowels, and now we need to make our 2 pointers, right? So we're going to make our 2 pointers. So we'll have a pointer I that starts at the beginning of the string, and a pointer J that's going to start at the end of the string. So you can say s.length -1. Great, so now the next thing is we need a character array, right? So we could actually manipulate the string that we have, and I'm just going to put it up here because our loop will go below. So I'll say we need a character array. We'll call this characters because it's going to be the characters of our string, and it's going to come from s.toChar array. So again, we're just converting the string to a character array because in Java, strings are immutable. Great, so now we have our 2 pointers, we have our characters that we can manipulate, and now we just need to say, wow, our pointers have not crossed, right, or touched. We know that we still have characters to check. So we could say, wow, I is less than j. We need to constantly keep checking for more characters, right, for more vowels to reverse. Great, so now we just want to find a vowel for the left pointer, right? So we want to find a pointer for our I pointer. So now, how are we going to do that? Well, we could just say keep continuing, right? Keep moving along while you don't have a vowel, right? While the character at the ith index is not a vowel, and while we haven't reached j. So that's as simple as saying while I is still less than j, and we're going to say not, but we're going to say vowels dot contains characters of I. And so what that's really saying is while the character at the ith index is not a vowel, right? Vowels does not contain that character, so it's not a vowel. And I is less than j, we're going to say increment I to keep trying to find that vowel that we're looking for. And now we need to do the same thing, right? So when the loop on line 19 breaks, we will hopefully have a vowel at our ith index, and now we need to do the same thing but for our jth index. So we're going to write the same exact loop but just for j. So while I is less than j again, and vowels does not contain characters j. So again, while the character at the jth index is not vowel, we're going to decrement j, right? Because j is going backwards. Great, so now if we've gotten to this point in the loop at line 19 and 22 broken, hopefully we actually have vowels to swap, right? So now we just need to actually do that swapping. So the first thing we want to do is store one of those variables. So we're going to say character temp equals characters at the ith index. At the ith index, and now since we stored that character, we can overwrite that character, right? So we could say characters of I is equal to characters of j, and now we could just put the temporary variable wherever characters j just was. So we could say characters j equals our temp. Great, so now the last thing we need to do to make sure we don't get stuck in an infinite loop is we need to increment I and j, or I should really say increment I and decrement j, so that once we've found those two vowels, swap them, we're going to move to the next vowels that we're interested in. Great, so now once this entire loop is finished on line 18, all we need to do is actually return a string with our vowels having been reversed. So now our character array actually contains those reversed vowels, so now we just need to return a new string from those characters. And that should just about do it. So now let's talk about our runtime, right? Our runtime is actually just going to be O of n, where n is the length or the number of characters in our string s. And a lot of people, I think, kind of get tripped up when they see loops inside of other loops, and they think it might be cubic or exponential and things like that, and that's not the case here. If you actually think about the logic here, we're really only passing through the string once, so regardless of what our code structure looks like, it's still O of n, right? This is running through the string once, so our runtime is going to be O of n. And then in terms of our space complexity, because Java has immutable strings, we need to make a copy of our string, so that's technically using O of n memory as well. So now let's run this code and make sure that it works. Awesome, and it does. So guys, that's how to solve reverse vowels of a string in Java. Again, it's a question that's being asked by Amazon right now. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more, and I'll see you guys next time. Put 100 bands in a duck bag. Put up in the ghost with a roof hat. Gucci from my toe to my do-rag. Walk in my fan. Came in a two-door fountain. Walk in my fan. Lil' Perk really got a bounce. Lean in my fountain. Came in a two-door fountain. Walk in my fountain.